um, working as a professor. Of course, there is some. No, no, fine, fine. No, 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 because already it is delayed. Afterwards, you can introduce. I'm teacher like you. I did my PhD and MTech both at IIT Kharagpur, and I have been working at NIT Warangal. Currently, professor. Of course, there is something HAG, something that what they call. And I have served earlier all other headship and all these things completed. I am working in data mining, machine learning, big data analytics. These are my areas. Fine. Okay. Yeah. In AI particularly, we want to introduce intelligence into an agent so that it also performs certain tasks. That's the point. Hence, the human way of doing a task is first we have some knowledge about how to perform it, and then literally we perform it physically. Hence, there is thinking involved, there is task doing involved, two kinds. Hence, that thinking can be done like humans, and acting. Hence, when we want to think like humans, first of all, we have to understand how the human thinking also evolving. Hence, it's a long history because who is the best human? You may be thinking better than me, or maybe the earlier generation, the next generation. Hence, finally, why I say that you may think better than me? Because the way you think and write a process, that optimizes the resources in performing the task. Hence, ultimately, what is important? Optimized way of thinking and optimized way of doing a task. We may be thinking that the way that we do, take this and put there is one way, but there may be the other way that an animal also do this same thing. If that is more optimal, we opt for that. Hence, the main goal of AI is optimal thinking, optimal performing the task. Hence, this thinking process is crucial. Then the next is performing the task. This thinking requires particularly prior learning. If I want to think on some topic, some prior learning and having knowledge about it, these two are prerequisites for thinking on that particular objects related to the task. Therefore, when we want to replace the humans with the machines, we have to see that machines also learn and then think. Later, according to its thinking process, some certain decision is taken, and accordingly the task is performed. When task has to be performed, then that agent requires the human kind of hands, and then we can think of that there is a robot which is moving like this and taking this and putting there, all these things. Hence, that's what the performance comes into picture. That is the latter part. Hence, the crucial part inside the AI is the machine learning. Machine learning. That learning, as I told you, it may start with the human thinking, but it may go beyond than the human thinking. That is ultimately optimal thinking process. This is what. Now, when I am bringing the human on one side, the machine on the other side, the human is learning how, by looking at the surrounding objects, interacting with the objects Object can be humans, and it can be anything. Hence, we are able to see, we are able to talk and listen. Therefore, with all these, we are interacting with the objects and getting the knowledge about the objects. Again, if I want to know about this, I may interact with you and get information about those objects. But my human mission cannot talk, cannot listen, cannot see. Therefore, what is the only way that it can learn? When it cannot interact with you, then people have thought that what is the best way, how you are doing it. Now when I am interacting with you, what is the crucial part? I am asking something and you are telling, then there is some conversation wherefrom I am able to get the something about the objects which we are discussing upon. Maybe we are talking about the vegetables or fruits. Then I may ask something and then you are telling about the vegetables and fruits. Then I will get the knowledge about those things. And when you are telling that, you are explaining that so the shape of that fruit is this, and its taste will be something like this, and color is something like this. These are all certain things which you are telling about one object, and finally saying that if an object has some shape S1 and T1 and color is red and so on, then that fruit is apple. Oh, then I came to know something about the apple. This perhaps you are telling and I am listening and storing it in my mind, and okay, I am exposed to apple. Then maybe another fruit, another vegetable, and so on and so forth. So many objects that I am being introduced by, of course, right from my childhood. My mother has introduced so many fruits and vegetables I came to know. Then later many other things I have seen. This is how I will get the knowledge about the objects. Okay. Hence ultimately, whether you are interacting or studying it, whatever it may be, the primary thing what we are dealing with is data. Data. Hence, this particular shape or this color red, it is a value for something called a feature. Hence, color, taste, shape, these are all certain features where these objects have the values. Hence, these values are being stored along with the class label, because that fruit is already named as apple. Now you cannot give your own name. Hence, you should know what is the name already given. Hence, the class labels are already attached. Therefore, among the objects, many objects are labeled objects. Some are unlabeled, of course. Hence, knowing about labeled objects, getting knowledge about labeled objects is one kind of learning. That learning is called supervised learning. Because supervisor is required, someone has to tell this is already named as apple. And someone has to tell, otherwise how, even God also, for the very first human being, God must have come and said that this is called apple. Hence, without supervisor, you cannot learn the labels of the objects. Therefore, supervisor learning is essential if you are aiming for the knowledge of labeled objects. Unlabeled objects, there is no name given to that, then we don't require supervisor at all. Therefore, unsupervised learning, there is a different task. Hence, now in this supervised learning, when we said that the objects are already labeled, those labels are like apple, orange, potato, tomato, like this. These are all what we call the classes. And our parents and teachers, friends, they are introducing these objects, and objects are having the values for certain features, and then the class labels. This kind of data is primarily getting registered in our mind, maybe through interaction or by looking at the objects or some different ways. Hence, people finally thought, maybe you are all struggling to get that data, but if I give that data directly into the system, well, system also has got that data, which you are acquiring with the help of your eyes and all these things. Hence, that's why they said that mission, though it do not have that capability of seeing, listening and talking, it can learn from data. Hence, data is crucial. Data is crucial. Hence, mission has to learn only from data, because the data, which is this, contains the introduction of the objects, everything. Hence, from this data only it has to learn something and then perform the task, whatever the task may be. Now, what is the task before us today? Classification. Hence, classification is a task, or some people call this as a knowledge. Okay, if you have this knowledge of classification, what task you can perform? Classify the objects. Hence, if you have classification knowledge, you can classify the objects. Then what do you mean by classifying the objects? No, you classify the vegetables, you classify fruits. Okay, you may be understanding, but if we go into deliberate it, what do you mean by classifying? Specifying the class. Specifying the class to which the object belongs to. Specifying the class to which object belongs. If I show an object, you are telling it is a marker pen. This is an object, it has a class label. Hence, this is marker pen. Hence, the class to which this object belongs to, that you are specifying. Hence, specifying the class is called classifying. For that, you require classification knowledge. Hence, that knowledge you can obtain only by learning from this kind of data. Where this kind of data means what? This is the data which you are receiving during training period. Hence, your mother is training you. Your mother is training you by showing so many vegetables and fruits. See, my daughter, these are all like this. You have to observe the shape of this object and taste it, color it, and then this is known as apple. That is also red, but it is called tomato, and something else potato, something else carrot. No, that is also red. Hence, like this. Then, during this training period, this much data is in your mind. Now, she will test you later whether you have learned properly during my training period or not. Hence, just one day before your marriage, your mother will show you an object. Come on, tell me. You see what is the color of this and shape of this? Now, if you tell, tomorrow your marriage is okay. Otherwise, we will postpone it. No? Fine. That's how she is asking me. She is giving an object X, giving you the values of the features, but now your mother is asking, specify the class. Specify the class. That if you do it, you are classified. Hence, instead of you, now mission has to take this training data, learn from that data, and perform this task of specifying the class of X. That's all. This is the problem before you. This is the problem before you, nothing else. Hence, what is the problem of classification? Given the training data, learn from this, classify the objects. Classify the objects like X, Y, Z. Learn from this. How to learn? That is what we have to think of. Where from? Training data. What is this training data? How training data looks like? There will be features. There will be a class label. The class label contains one class C1, another class C2, C3. There may be another apple, green apple may be there. C1 repeated. Hence there are certain classes. How many classes? Maybe 10,000 vegetables and 20,000 fruits. Some C1, C2, Cm number of classes. M number of classes for which you have seen so many thousands of objects having features F1, F2, F3 and so on, Fn. N number of features. Some 10 features, 20 features, 100 features, 3000 features. But how your mother knows that these 10 features are enough to recognize or to have complete knowledge about the features means she knows. We don't know that because that is called feature engineering. Whether those 10 features or 100 features, 3000 features, whatever you have taken, are they all necessary? Are they sufficient? That is a different question. That question which we discuss in a topic called feature engineering. Hence that I am not stepping into now because that itself is a ocean. Hence we assume that someone has well thought of it and they have fixed that this n, whatever it may be, n, 10, 20, 3000, whatever it may be, certain n features, they are all necessary and they are sufficient. There is no unnecessary feature and nothing more is required, therefore they are all sufficient. Let us assume that. Okay. But how to extract that, how your mother knows that she should ask you to think of, see the shape, taste it, color it instead of something else. That's what I said, no? Features they have extracted. Hence for an object, what are the features that you have to look into? These are all, because some people know, once they go, no, vegetable, drumstick, they will just twist it and they will observe it. Hence whether it should be first twist and then see, then lady's finger, they will cut it at the end. Hence which feature that indicates it is the proper thing or not, they are all trained. That's what the point. Hence someone has thought of these features and they have listed it. They are all necessary and sufficient. That we are not stepping into. But feature extraction, feature naming, noting down, working on necessary thing and sufficientness, that's what the feature engineering, that is one of the very good topic. Where some automation also took place, I am stepping, though I am not teaching it, I am stepping into that a little bit. How you can learn it automatically, then is it possible with neural networks? Now deep learning, okay, your convolution neural networks, CNN, these are all helping you to extract the features automatically. That's what happening. That is a aside. And once the given features, all are they sufficient, which feature should be taken, whether sometimes 2-3 features putting together, can we rename it, new feature is constructed, all these things that we do in principal component analysis, this kind of dimensional reduction techniques. These are all what we discuss in feature engineering. That part we are not touching it. Hence now, the problem of classification is, still I am at the problem, because we have to understand the problem well. Given the training data, hence what is the training data? Oh, in the board he has written, there will be n features and, namaste. Yeah. Sorry. Yeah, we started nearly.
Much for accepting our invitation.
No.
Yeah,
Yeah.
I'm very happy.
Thanks. Thank you.
You are a part of our FDP. Thank you very much.
Nice one.
ఒక్క నిమిషం.
Run.
Sir, be here. అవుతుంది సార్ వద్దదు.
Yeah. It is a bit delayed, that's why I am also in a hurry. Just telling very important points and introducing the topic. Fine.
Well, it is all. Thanks, sir, for with the round of applause. But these are all protocols, otherwise I will not.
Yeah, I understand. These are required, we also do it. Fine. Hence, this training data consists of certain n features, and there will be certain objects having the values of the features and the class. Hence, these values of the features, this is primarily data. Primarily data is this. Okay, this data somehow contains the knowledge. Knowledge is hidden in this data. Knowledge is hidden in this data. That knowledge we have to extract. That extraction, discovery of knowledge, when I said hidden, it means you have to discover it. When you discover the knowledge from this data, then you will get the knowledge. That discovery process itself is what we call learning. Hence, learning is that. Hence, by learning, you extract knowledge from the data. That's the goal. Which knowledge? We don't know. The knowledge required to perform the task. What is the task before you? Specify the class. Hence, whatever the knowledge required for that task, you get that knowledge is here. That's all. Believe that the knowledge is here. Now come on, design an algorithm or think of the process, how to get that knowledge hidden in this data so that I can perform the task. Okay? That's the problem before you. Now people started thinking, my mother is training, I am receiving training, somehow I am picking up that learning is taking place. Now again, after seeing those fruits and vegetables, I am able to specify the names and all these things, I am able to classify. But what is that is going on in my mind? Till now it is quite natural. Okay, this kind of table data may be there in my mind, everything fine. But how you are doing it? How my mind is doing? How learning is taking place? Then people have started. There are so many approaches for this classification problem. So many approaches. And so one such approach we start now. Similarly, we can think of the other approaches. Okay. One approach is, okay, they started looking at somehow how to get the knowledge. No, I am not able to get any idea, sir. You have drawn something red and S1 something. Okay, I can fill up the rest of the blanks also, but no use, no idea I am getting. Why you are not getting idea? No, you are already delayed, late, you are teaching in hurry burry. No, you are not a good teacher, you are a poor teacher, hopeless. My mother was a good teacher. She taught well. There was no confusion at all. You are not a good teacher. You are bringing sometimes AI, machine learning, feature engineering, CNN, PCA. Nothing you are teaching so far. You have already mixed up so many things. You are not a good teacher at all. Unnecessarily our people have brought you out the way from Warangal. Okay, why you are naming that I am not good teacher, rather bad teacher? No, I am mixing up. Oh, your mother? Never. She has patience. She has seen that you have learnt alphabet A, then only she introduced alphabet B. She introduced apple. When you properly recognize apple, then only she introduced tomato. Again, she knows that you got confused. Both are red color, but still somehow she made you to learn and distinguish both. And then brought carrot. It is also red, but still confusion arises in you. That confusion she removed. She slowly, naturally she has taught. That's why she is good teacher. Hence the difference between your mother and me is that not that she has patience, I don't have patience, I am also okay, I will stay here for 10 days, no problem, people will feed us, not that. I am mixing up. Hence you see, sometimes when someone giving lecture, we say, oh, this fellow is mixing up, oh, he will go this way, that way, that way. You would have taught in an organized manner. Why it was not, okay, that's the point. Hence, I have mixed up the objects belonging to various classes. Apple is there, tomato is there. Does it mean if I sort it on class, will this mixing will go? No, that will not go that way. Hence, only thing what they understood is this is a mixture of objects belonging to various classes. Hence, even the researcher has to look this way, that most of the problems in the machine learning are mixture problems. Hence, what kind of mixture it is? Of course, even the high-level research, what we are doing it, is it a Gaussian mixture model? Which mixture that we have to think of it, and accordingly we have to think of it, see the solution. Hence, they found that being it is a mixture, I am not getting any idea. Why you are not getting any idea? To see the knowledge hidden in this data, how to get the knowledge, take the knowledge out of this. I am not getting idea, you are not getting idea, for the reason it is mixture. When they found that the reason is mixture, that's what happens. If I take milk in one, if I ask what is this? Milk. If I show you this, water. But if I mix up these two, then if I show that, oh, this is neither milk nor water, sir, it is liquid. It is a mixture. You are unable to classify. It is a mixture. When mixture is there is ambiguity, confusion. You demix it. How to demix, we don't know. There may be a process. You may be keeping on the stove and then let water be evaporated, then you got milk. And evaporated water is again condensed, water is separated, separated. You do whatever the way. There may be some way of separating it. You demix it, then naturally you go. Hence what we have to do when we see this mixture on this data, first step is what? Demix it. That's the idea that. Hence the researcher who started thinking in this, some approach I need for classification, he looked at why I am not getting idea. It is a mixture. Oh, it is mixed. Someone has mixed it. What I have to do? Demix it. Now come on, start demixing. How to demix? Like I said, no, the water, this. How now here, how to demix it? It is something like your father brought vegetables, fruits in a bag from the market. All tomato, apple, these are all there. Now you pour it on the ground, you call a child, she starts demixing. Demixing means if you call some 6th standard high school student in your family, she knows apple, therefore she will pick up all apples and put separate. Tomato, she will put it. No, my mission don't know which is apple. It is yet to learn, it is learning. Hence it cannot see, it cannot recognize this is apple, this is tomato, hence apples are separated, tomatoes are segregated. No, not that kind. Here demixing should happen even though I don't know the object name is apple, this. Maybe it is written on that, but I don't know, I am not yet joined LKG, but I can see it. Hence, I can see it means, okay, all red colored objects I will put separately. Next, this is not red, okay, I will put here. And the red color, among this again I will see it is a mixture. Then I will taste it. Oh, this is one taste, this is different taste, this is same taste, and this is another taste. On taste I will further segregate it. Hence, my demixing process is to happen only on the features. Then again you may ask, sir, you are bringing a child who can taste and who can see the color, but my mission cannot see. Mission cannot see, but mission can see the values. After all, suppose you want to segregate this, demix it on shape, what you have to do? You take out all this S1, this object you take it. If second object is S2, this is a different value. Put it in another group. Again S1 has come, you put it in the previous group. S3, you formulate third group. Based on the values only it has to segregate, that's all. Recognizing this S1 is different from S2, of course your input organs are helping. After all, it will look at the values of the objects and thereby it can segregate it. Hence, this demixing is not at all a problem. But the question is, first I should start on what? Should I start demixing on color? Or should I demix on taste? Is it not? First I can see. First what I said, you segregate on color, put red, green, yellow. No, why sir, first you are segregating on color, why not you segregate on shape? Yeah, that also can be done. Hence, consider this. Maybe on color you are segregating all the red color objects from this data set D on this third feature color. I am segregating. The red are placed separately and green D2 and something like that, yellow D3, something next is D4, maybe only 4 or 5 or 10, some. How many? It depends on how many different values that this color has in that particular data set. Then thereby this D is segregated into D1, D2, D3, D4. Now is D1 a mixture? D1 is a subset of objects given in the original training data. Like, your tomato, apple, carrot, these are all being red, you have placed them. Is it a mixture? Yes, it is a mixture. It's a mixture. Whenever it is a mixture, what is that your idea? Demix it. Now how you will demix? Can you demix again on color? No, color already done. Now you have to use another feature, maybe shape. Now you demix it. Maybe S1, S3, S5, S2, S4 is not there. Hence D1 is further segregated into D11, D12, D13. Again is D11 mixture? Fix, segregate it. Now it may be on taste. Now the question is, how long, how much depth this tree will grow. This is tree kind. How much depth this tree will grow? Number of features, because you have used one feature here. Another feature, suppose there are only 5 features, F3 is used, F1 is used here, F2, and then maybe F5 and then F4. Maximum 5. Now what happens afterwards? No features, but what will happen here? See the data, here there were 1000 objects. The 1000 objects, 150 were red color. The remaining, some are green, some are yellow. All 1000 are distributed. Now out of this 150 again some 35 here, some 25 here, something like that. That's how coming. Hence here also you are getting one set dead D prime, another set called D double prime. How that D prime set looks like? Objects having same color, same shape, same taste, same F5 value, same F4 value. Fine. Hence, this particular D prime will be, shape is S1, is it not? All these objects will be what? Same shape, S1, S1, same taste, same color, red, 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 so on. Hence, whatever the number of objects may be, whether 5 or 10, whatever that, all those objects, they have same features. They have same features. Therefore, if one object is C3, being all other objects also having same features, they are all, they may be C3, okay, C3. Hence, then you attach the leaf label labeled as C3, labeled as C3. Fine. Hence, it looks that we have reached a logical end, but here there is some dilemma in some minds. If these 5 features are same, if it is C3, the next object 15, this is also having same features, will it be definitely C3, sir? If all are C3, you write C3. Suppose you encounter in your life some training data set that there are 20 objects. How many objects are there? 20 objects, in which 16 are C3, or 2 are C1, 2 are C4, then this is also a mixer. This is also a mixer, is it not? Do they belong to same class? No. What do you mean by mixer? If objects belonging to various classes in one place, mixer. If the objects are all of same class, non-mixer. Hence, whenever you see a mixer, you are demixing it. Here, one case is what? This D prime, is it a mixer or non-mixer? Non-mixer, this C3. I have assumed initially all are C3. If all are C3, no doubt it is a non-mixer. You can stop this demixing process. The moment it is all a non-mixer, oh, all are tomatoes, that's all, C3. Knowledge is very clear. When there is a confusion, no, the moment I say, ah, now I got it. Knowledge is that, that's all. When things are clear, then we will see that, yeah, knowledge has come. Oh, when things are visible, yeah, light has come. It's something like light only. Your knowledge is like something light. You are searching for something. Yeah, okay, I got it. Knowledge is that. Hence now, this is what. Whereas if you have still suspicion that this D prime, there may be another D double prime, where just now I said that there are 20 objects, but not are all C3, there may be a few, this, then it is still a mixer. If it is a mixer, what we have to do? We have to segregate it. We have to segregate it. So if you want to segregate, you want to demix it, what you require? Feature is required. Do you have feature? No. Hence, in the given training data, it is so happened that you reached a D double prime where you badly need a feature but no feature available. Therefore, you cannot demix it, and they are not belong to same class. Therefore, you cannot attach a leaf node. You cannot attach a leaf node. You cannot attach a internal node. So that these are all internal nodes, no, where demixing is happening. But that cannot be continued because you don't have features. Hence, this kind of situation, if at all if it arises, it tells you that the taken features is insufficient. Very simple. No, sir, this situation is not at all arising in any branch you go. Always, either I will have mixer, otherwise I will have clearly non-mixer. When I have a mixer, I have a feature to segregate it. But this is the place where you got that it is still a mixer, but you don't have features in hand. The training that all the features are already used. This will indicate that insufficient features are taken. Then by? If there is no mixer, knowledge is very clear. No, what is the question? Yeah, we are learning here. No. In mixer, then some task is required to learn it. That's all. No, I will come to that. Okay. Let me continue because now already a lot of things I have to teach. Okay. Hence, in this situation, what is the way out? I cannot live like this. I cannot live like this without attaching internal node or leaf node. Some solution has to come out. Then people, what we generally recommend, no, you have forgotten some feature, you go back and repeat the experiment. Maybe already you have taken 100 features. Maybe some more is required. How many more, I don't know. I can only tell that it is mixed. Yeah, maybe just one feature may segregate into two proper classes, or 2 more, 3 more features are required, I don't know. You go back. That fellow will tell, no, repeating experiment costly, 1 crore is required. It doesn't matter, you somehow finish off it. Somehow finish off it means what we do, we go by majority. If majority of the objects belong to what? Some C3, because already I have used a C3, let me say this C5. Then majority of the objects belong to C5, therefore I will attach C5. If I attach C5, what will happen if I follow this particular chart, whatever this figure, this model, these 4 objects also classified as what? C5. But the training data is telling that 2 of them are C1, 2 of them are C4. Hence your model, your algorithm, your approach is deciding them as C5, but the reality is different. It means 4 objects are misclassified. 4 objects are misclassified, means accuracy gone down. Hence, whether how much accuracy is there. Hence, there are metrics.
that they will look at whether your algorithm is enjoying this much accuracy, precision. So many metrics are there that we will look into. Hence, what are the metrics? Which metric means what? That is one discussion. Okay, that's what can be done. That's why, otherwise, no, if every process is good, then we don't require metric. We don't require any metric. Every process definitely it will take ultimate to the God. Then you follow this route and reach the God. Oh, no problem, truth. But there is a problem. You will see that, oh, I reached God, but you have not reached God. Means then we have to test whether you have really seen God or not. That's the only point. Hence, that's why we need some metric to measure. That's why we are measuring. So these measures are all happened because of that. On the other hand, now here you have seen either mixer or non-mixer. This non-mixer case is, this is non-mixer, this is mixer. This mixer also somehow I attached what? Leaf node by taking majority of them, though it is an approximation. It is bringing some error into the system, but still I have to, because 1 crore I cannot spend to repeat the experiment. Hence, how many features are used? 5 features before I reach the leaf node. Now, the next question started in the minds of those initial scientists. Is it required that every path from the root to the leaf must contain n features? Sequence may be different, color, shape, taste. Here I may get a taste and then this. Hence, whether same sequence should be there or different sequence possible, whether all the features must be there between the root and the leaf, or sometimes here itself I can attach a leaf node. Oh, in this leaf node attached means along this path only 2 features are used. What happened to the remaining? Will it happen or not? If may means what? When? How to know that, oh, I can attach a leaf node, I should not attach leaf node, still I have to go. That you have to see. Because it is labeling, no? Hence you are labeled as professor. How you know if suppose in LKG itself, if you know that you are professor, you might have not studied. I will become professor in Afghanistan, no problem. I need not write this 10th class, intermediate, all is assured. Life is deterministic. Hence, you are every moment you are struggling. After 10th class, should I stop? Whether I am labeled here or should I continue? Whether I stop at +2, should I label or continue? And there were some people who stopped at +2 or BTech, they became labeled, different labels they got. Hence, whether to stop here and get your label or you continue. How to recognize when to stop? Very simple, already we discussed. When you are stopping, when you can stop? If it is a non-mixer, suppose here you get a non-mixer, then you stop. How to say whether it is a non-mixer or not? Very simple. If all the objects belong to same class, non-mixer. Different classes, mixer. Hence, every moment you have to check, should I attach leaf node or internal node, depends on whether it is non-mixer. Non-mixer means leaf node. Mixer means intermediate. Which feature you have to bring some feature here and segregate it. That's how it goes. Here, suppose these two, Here, what is this? D11, D12, D13. In D13, how D13 looks like? How D13 looks like? That is set of objects which have same color, same shape. That's all. But taste and all we don't know, may be different. Hence, F1 is same, F1 is same, and F3 color is also same. Some say, suppose color 4, green, 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 all green. But taste may be one is T1, another is T2, again T1, again T4. Taste may be different. Other F4, F5 values may be different, but they belong to same class, C6, 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 C6. It happens. Though some features are different, they belong to same class. They agree on some features, they disagree on some features, but they belong to same class. That is fact. You can observe that in the data. In the data what you have got it. Hence, if D13 is non-mixer, attach leaf node. What is that leaf node? C6. Leaf node labeled with C6. You just put a leaf node and write C6. If they all not belong to the same class, you take another feature, segregate it. That's all, quite simple. Which one? No, how many features already you know, no? That is Fn. The maximum this will go up to what? N. But if you are lucky, you may get the leaf node attached at early. See, this is the tree structure. Not all leaves after 10. Not all leaves are at the same depth from the root. Sometimes very sharp, sometimes long branches. That's how this particular demixing process, very simple idea. Demixing is the only idea which we have started with on the training data, because we were struggling. Why I am not getting idea? Why I am not getting idea? Oh, this is mixer. Hence, what to do? What to do with mixer? Demix it. That idea that fellow got, how he got, we don't know. The demixing process could able to construct this, the whole kind. And all other things which are quite natural questions, natural answers have come up. But one breakthrough idea was, he has seen that data as a mixer data. Idea of demixing was the good idea. That's how the research suddenly, that the sparks come. Yeah. Over. Then we have got a tree kind of structure which is helping us to decide the class. They named this approach as decision tree construction. Decision tree based learning. Hence, decision tree construction and using decision tree became one model, one algorithm, one approach for the problem of classification. Okay. But then people started thinking, just now we started at one point of time in our discussion, should I start with color? Suppose you start with color and you got something. He started, no, I will start with the shape, sir. He might have got another tree. Which is better? Already I told, who is better between you and me? Whoever optimizes. If your tree is cute, small in the sense the number of nodes and branches compared to this, yeah, then yours is good. Because if the number of branches and the nodes are less, quickly decisions are being taken here. Whereas here, going deep. Then if I ask how you got that idea, I don't know, sir. I started shape. I am lucky I got it. No, that cannot be. Because for the mission, I cannot bet on luck. No, we are all by luck we have reached here. Why am I at NIT Warangal? Why you are here? Why the other fellow is still pulling rickshaw? We don't know. All by luck. Not by knowing that this path will take me to NIT Warangal, MJCET. No, not that. Somehow, that way I cannot leave. Because this is science I am developing the logic. Then people started looking at any scientific way of attacking this. Which hence here I have n features, f1, f2, f3, f4, fn or 5, whatever it may be. Out of these 5, one you have to select. But which one is the best? Which one is the best? Not by constructing and seeing. No. Is there any scientific way of attacking? Oh, out of these 5, this is. What is that? No, you tell. Pure. Oh. You are great. Hence he has brought something word called pure, because he is enjoying, he is living with a pure heart. Even I like purity. Morning I want pure milk, but that fellow will mix up already. I want pure friendship. I want pure people, pure food. Everyone wants purity. But unfortunately, already it is impurity there in the mixture. Water is pure, milk is pure. But if you mix up, both got impurity. Hence, the very problem with the mixture is, whether it is air pollution, whatever it may be, any mixture, we don't hate mixture. We are hating because the mixture is suffering from impurity. Mixture is suffering from impurity. That's why we don't want mixture. Right from beginning. Otherwise, people do not hate mixture. The mixture has the problem with impurity. That's why everywhere people want to get segregated. We all will go, you go that way. Because we are a different person. Mixing up is not good. But we live in harmony. In several ways. People have fun. Unless now struggles, battles are there between two groups. Forget. God has given that enough thing. Live separately, live in harmony. Because mixture will bring impurities. Hence, we hate mixture because the impurity is involved. And the demixing process, what it is bringing back? The purity. Why we have adopted demixing process? Because there is a hope that purity is again regained. Hence, the whole demixing process, what you have done to the decision tree construction, is to eliminate impurity. Therefore, out of n features, which is better,
That is the question before you. Which is better I can tell if I know what it is doing. Oh, color is demixing. Demixing is why? To reduce impurity. That's what now we understood. The demixing is what? To reduce impurity. Therefore, color will reduce impurity. Even you use shape, it is also reducing impurity. Suppose doctor has diagnosed, they said that this much impurity is there in your blood and medicines are there. This my impurity in my blood is 10 liters. Some I don't know what is that impurity, how it is, someone measured it. 10 quantity is 10 units. If you use medicine 1, this 10 liters will be reduced to 7 liters. If you use medicine 2, the same 10 liters will be reduced to 3 liters. Something like this. Another medicine 3 will reduce 10 liters to 5 liters. Which one you prefer? M2, because the reduction impurity is reduced no to 3 liters. The leftover is, this is leftover. This is original, total impurity, leftover. Thereby, how much impurity is removed? 3 liters only. Here 7 liters removed. Hence, amount of impurity reduced. Amount of impurity reduced because of feature 1, first medicine. Feature 2, if I can calculate this, for each feature, amount of impurity reduced, amount of impurity reduced. If I can calculate for each feature, then whichever feature reduces more, oh, this is reducing more, 7 liters is removed. Oh, great, let me use that. Hence, which feature best? The one which reduces more impurity at the first hand. Because then what of is reduced now? Great relief, now the rest will be reduced by next medicine. Something like that. See, this is again a breakthrough research, happened in 1986 or so. This is again breakthrough. That demixing is one breakthrough. Now another breakthrough has happened. But now we require what? How much total impurity was there originally, minus how much leftover. These two things I need some formula. How to calculate total impurity? Then I will get this. Hence, your data in training data, when I said that it is a mixer, it means it contains impurity. Mixer contains impurity. Agreed. If impurity is 0, that would have been a non-mixer. Impurity is present means it is a mixer. But whatever that impurity, I have to calculate. Some impurity I have to calculate. How to calculate impurity? Then they started in that team, they started thinking of some formula should be there, so that if I give this data, oh, this data is given, my formula is calculating, telling that this much impurity is there in this data. Then they started thinking how to calculate impurity in the given data. Then one sub-team, you start thinking on this, another fellow will think another one. Okay, now you started taking your team, your sub-team, started thinking how to design a formula to calculate impurity in the given data set. Then finally tomorrow morning or after 10 days you will come back. Sir, you need no, we need not formulate a new formula, already a formula available in the literature. That formula we will use it. Okay, no problem.
This problem is already formalized there, let us use it. Why you have to, very good idea, at least. Instead of creating new medicine, already medicine available, sir, okay, need not reinventing, required. There was one fellow, Shannon, somewhere he born in 1940s. That Shannon, he has designed one concept called entropy. Shannon's entropy. Of course, he found that in some context. That exactly it will not be useful, but that concept is useful. Huh? No, sir. You have mechanical background? Studied somewhere, high school, 10th class. Hence, this entropy, he is telling thermodynamics. Some person will tell image processing. Some other person will say in physics. Some other person will say in machine learning. Some other person will say in information coding theory. Hence, this entropy is occurring in so many courses. Whether the formula is the same? No, slightly different. Hence, this entropy is a concept. That concept you have to understand it. That's what happened. When Shannon found this and then he went to, he was doing research in MIT. Okay. Then he said, this is the concept, you are old man, elderly person, in coffee shop, you are one Newman was there in that. This fellow is young, Shannon. He's a very intellectual person, this fellow. Somehow he will go underground and again he will come. He rides on a single cycle. There are so many kinds. Okay, fine. Hence, one Newman named, you name this as entropy, no one will understand it. Hence, he put that curse. This concept is very beautiful. You have designed very nice formula. Since you have asked me to name it, I am naming entropy. No one will understand it. No one will understand it fully. That's what still people are trying to use. How many places, how many ways that entropy can be used, still people are finding. It means still we are unable to understand it fully. That's the point. That one Newman is another great mathematician, great thinker. Entropy. Hence, you calculate entropy, you will get the total impurity, leftover impurity. Then you will formula will be ready. Then thereby you can have the whole process. Now what is time? Okay, someone should. Huh? 37. Another only 7 minutes. Someone should take me. Whether HOD is there? I requested him. I have to leave by 11:45 because I have to catch 2 o'clock flight. 2 o'clock flight means I should be there by 1:45 minutes journey from here. Entropy. Hence, entropy formula. Have you studied this entropy somewhere? No, thermodynamics, this. But she may tell, no sir, in computer networks, Shannon's entropy, I have studied it. Computer networks, machine learning I am using now. Already in computer networks in physical layer, you see now, open today Tannenbaum, in physical layer, Shannon's entropy is there. Yeah. Signal to noise ratio, logarithm, signal to noise ratio. Okay? Signal to noise. Because the very experiment what he was doing is, there is a media, there is some information, hence this information has to be coded, then there will be data, the data will be transmitted, the other side the code will be received. Hence the physical layer, information coded, communication is taking place. in the communication, if different media, copper media, this media, that media, then once on the other side, here the bits will be garbled. Error may happen. Noise is taking this signal, and the signal line is supposed to move like this. This particular which is supposed to be on the signal line is placed here. The noise is pulling. Therefore, the points will be like this. If it is like this, means you have as much signal strength and noise strength is there, then the quality is very poor. Hence, all these things you study there. Entropy. Hence, therefore, how much impurity is there in that communication part, the communication media. That's why we want a perfect media to transmit the information. Hence, information coding theory, data communication, all this involves net entropy, because everywhere no noise, impurity. Hence, that they have found like this. But here there is nothing like signal to noise. Here something else we use. What is that? The pi log pi base 2. Okay. Here pi is the probability that an arbitrary object belongs to class Ci. Probability with which an arbitrary object belongs to class Ci. Ci means how many Ci's are there? M number, M, C1, C2, Cm. Hence, this I runs from 1 to M. Hence, P1 is what? Probability with which an arbitrary object belongs to C1. P2, C2. Hence, if I choose someone at arbitrarily, someone chosen at random, what is the probability that he belongs to C1? Hence, in a class of 100, some are getting into Microsoft, some are getting into this happening. Hence, now you are checking what is the chance that if someone is picked up at random, he will get job in Microsoft. Can you tell? Do you have such probability? How? Suppose the moment the parent and the student join, he will ask, sir, what are the chances my boy gets in Microsoft if I admit him in this MJCET? Then that security fellow will tell, no, your boy, no, which company? Microsoft. Okay. He will tell. Probability of getting in Microsoft is 3 by 3, 420. Something he will tell. And okay, Microsoft 3 by 300. Okay, this fellow father, as he understood, okay, this. What happens with TCS? TCS 15 by 420. Next, you bring your child. You ask Microsoft, he will tell 3 by 420. You ask about TCS, 15 by 420. Whoever asks for Microsoft, he will tell 3 by 420. Whoever asks TCS is telling 15 by 420. How? The security fellow don't know. Every year, 420 people enter into MJCET. After 4 years, when they are going out, 15 of them, they said, we got TCS jobs. 3 of them, they are saying that we got Microsoft. This has been happening. This has been happening. Therefore, we don't know what is the capacity of input, what is happening inside. Are they taking snacks or something happening inside studies or not? Don't know. 420 people joining, 3 are going out, Microsoft. 15 are going with TCS. Since you have asked Microsoft, I will say 3 by 4. 15 by. That's fine. It means, irrespective of the student in the class, chances of you getting in Microsoft is 3 by 420. For you also, 3 by 420. Hence, everyone has the same chances of getting in Microsoft. Do you agree? He is not agreeing and you are agreeing. Why you are agreeing, why he is disagreeing? Now we have to debate, but I don't have time. That's the problem. The problem is, he is telling that, no sir, I have more logical thinking, I have more communication. How you say that my chances and his chances are same? Yeah. No. You might say. Hence, knowing about you, chances of getting in Microsoft, knowing about why, chances of getting Microsoft is different. This is what we call conditional probability, posteriori probability, after knowing about the candidate. Hence, instead of asking that security fellow, if you go to a placement officer, he will ask, oh, what is your JE rank? How much good communication, how much logical thinking? Okay, then you are like a symbol, those 10 fellows got Microsoft, therefore your chance is this. Oh, you are like this, you will get this. Hence, knowing about the object, this is posteriori probability. What we are calculating here is the priori probability. The priori means beforehand, before knowing it. Hence, this priori probability, it is same for all. At the time of birth, all have same chances of getting prime ministership. But afterwards, slowly, your chances, as you know well, as you unfold yourself, then the chances increasing. That's what. Therefore, here we use the priori probability. It's very simple. Just by total number of students and how many got this. It means in your data training data set, total number of objects, how many are labeled as C1, that is P1. How many are labeled as C2, that is P2. Hence P1, P2, P3 is known. This is known. But how you say, sir, entropy, you have constructed some formula, all gimmicks you are doing right from morning. How to believe that this indicates impurity? We are struggling the impurity measurement. You said that this is impurity. Suppose there is a set of objects belong to same class. Belongs to same class. Means 20 objects or 240 objects. All 240 belong to same class. C1, C1, C1. Then what is P1? 1. What is P2? 0. P3? 0. Now you put in this, you expand this summation. P1 log P1, P2 log P2, P3 log P3, all are zeros, 1 log 1 is 0, hence totally what? 0. If all the objects belong to same class, what is this sum indicates? 0. It means impurity is 0. Impurity is non-zero given by this formula means there is impurity, then you have to calculate it. The leftover is very simple. D has impurity. How much leftover after color? After color you got D1, D2, D3. In D1 how much impurity is there? How much impurity in this? How much impurity in this? Sum of the impurities in each of that is called leftover impurity. Leftover is something leftover in D1, something leftover in D2, something leftover in D3. Now putting all together you will get it. Hope the rest you will understand.
Let us welcome Mr. Anand Panchbhai, co-founder Logi AI. Let me hand over the mic to Ms. Amina for a brief profile of Sir.
I'm Amina Tabassum, Assistant Professor of Computer Science and Engineering Department. It is my distinct pleasure to introduce our expert session speaker, Mr. Anand Panchbhai Sir. Sir is the co-founder and executive director of Logi.ai, a health tech startup leveraging artificial intelligence to make early disease screening more accessible through smartphones and WhatsApp-based solutions. Sir has graduated from the Indian Institute of Technology, Bhilai, and has strong background in AI, computer vision, and digital healthcare. He has co-authored peer-reviewed publications, contributed to patented AI technologies, and received recognition through programs such as BIRAC Ignition Grant, the NITI Entrepreneur in Residence Fellowship, and the Smart India Hackathon. His work is centered on using AI to build scalable, affordable healthcare solutions that expand access to quality diagnostics. They empower some of the biggest products and services brand in the healthcare industry to take first step towards providing meaningful value-based care and touched the lives of more than 150,000 people in the last 6 months and honored many national and international awards. May I now have the honor of inviting Mr. Anand Panchbhai, co-founder of Logi.ai, to kindly join us to share insights on the challenges of deploying generative AI healthcare systems in production. Please welcome, sir.
So I'm Anand. So I've been working on AI for a very long time now. It's been like 7 years or 8 years. I started my company when I was in college. It's into AI healthcare. So let me just get you an understanding of what we do. So do you guys use Colgate for brushing and all? Yeah? So let's say you may use it. Yeah, so you may use any toothpaste, but yeah, let me tell what we do before we delve into how we do it, right? So that you get an idea of where the dots are going to connect eventually. So this is what we do.
Everyone. Now get your AI dental screening report through a chatbot on WhatsApp and a free dentist consultation near you in an instant. It's super simple. Let me show you how. Scan the QR code on any Colgate pack and start the AI dental screening on your WhatsApp. Answer a few questions. Upload 3 images of your mouth. Your free AI dental screening report is generated in an instant, indicating presence of cavities, stains, and gum issues. And look, it's a personalized report too. Next, you can share your PIN code and find a dentist near you to book your free consultation. It's time for you to prioritize your oral health. Take the AI-powered dental screening for yourself and share this with your friends and family too. Join the Colgate oral health movement now.
Do you have any questions about what we just saw? Anything you didn't understand? Right. So that is what we are going to look at. So we'll look at it from an example of the cataract screening. I think the first session is about the cataract paper, as far as I know. I think our 12 AM session is about clinical validation of artificial intelligence-based cataract screening solution, right? So I think my later session is about deploying healthcare system with generative AI. That session will have more hands-on place where we'll try to develop something, and I'll show you what kind of tools we use today to make applications. Not that we write, and given the sessions are like time, we'll be using a lot of LLM, so I hope you'll get a good exposure to that too. So in the first session, I'll just go through my presentation on this clinical trials, how we do it. And the second session, we have the hands-on session. I hope we are clear on that. Am I not audible to everyone? Maybe. Can you increase the volume or something? Try to train the AI to do what we have understood. Okay. So today we are going to learn about how a simple cataract AI detection is done. So before we get into it, like major part of blindness in India is mostly due to cataract, right? Because it's because of aging, and almost a big population is going to go through a cataract surgery. It's part of your insurance, so no worry about it. But still, even in urban India, when people are not able to see clearly, they just think that, okay, I'm getting old, that's why I'm not able to see clearly, and they just ignore cataract. Okay, it's just because I'm getting old, because you get a lot of, let's say you are not able to read nearby things and all. So people are not aware that it's a treatable thing. You can do a surgery, clean it up. What is cataract basically? On your eyes, through the lens that you see, it becomes a little foggy as you grow, right? And then what the doctor does it replaces the natural lens and replaces it with an artificial lens so that you can see clearly, right? And if you don't do it in the right time, you delay it a lot, it can lead to blindness. So that's the issue with cataract. We work with a lot of hospitals to detect such diseases. Okay, we'll come to know how we do it. So this is like the photo of an eye, right? This is a normal left eye, this is a normal right eye, right? In this you see, this is the place we look at. Okay, given we are going to be talking about a lot of medical things, so just get used to such events. So this is the lens, right? Yeah, so from there the light goes in, then it gets inverted and is projected on the retina. Retina is the sensor in our eye that eventually sends signals to our brain as to what we are seeing, right? But when a cataract develops, it looks like this, right? Now, you don't have to do the cataract surgery as soon as the fogginess comes. You can still see, you can use a couple of lenses to still see. You have to wait. So we have immature cataract where you don't have to go for the surgery right now, and then we have mature cataract when it is very opaque, right? That is the point we do this surgery. Okay, so we do it again using the phones the way we did for oral care. We take the photo of your eye, the left eye and the right eye, and then it generates a result. Okay, so our partner hospitals, what they do is, morning a lot of old folks go to this gardens to walk, right? And there are so many areas where so many people gather up. They just put up a stall, they ask people to come, so it's a way for them to get new patients and to spread awareness about cataract. Are we clear about the applications? Any questions so far? All right. Now, when you want to build such a system, we saw that images are going to be our input. So we'll need a lot of images for to train our eyes as well as to train an AI. So the first is, we want to take images. We have certain things like flashlights, 2x zoom. It should be a dim room so that the flash can work really well, right? Then we use WhatsApp here as a medium to send the images to our servers. And then we run our inferences and all, and then we generate the report. In this case, we use a model called as YOLO. So do you know how an AI detects anything on an image? Any idea? This is what an input image looks like. Okay, this is an image. What we do is, in this image we create a lot of small boxes, right? What is detection and classification, the difference? Right? Okay, so I just don't know the context. I'm asking basic questions so that anything is answered. Okay, so see, this is the input image, right? So when you get an image of an eye, we try to first of all convert this into a bunch of matrices, right? We want to do feature extraction from this, right? Once we do the feature extraction, we feed it to our YOLO models. Then they give us bounding classes, and confidence. So let's say you have an image of an eye. What we do is we create 4 or 5 or hundreds of proposals on it. What is a proposal? It's a box. And it's a box which has a probability. Is it a cataract or is it not cataract? Let's say there are 100 boxes here. Each of those boxes then goes through our classifiers. And then each of those classifiers tells us, is it cataract, not cataract, cataract, not cataract. For each we'll have a confidence, a class, whether it's normal, immature or mature. And that's the bounding box, that's the proposal. Are we clear about this pipeline? Right? Proposals are basically boxes on that image. Then we go through our classifier. For now, let's just consider it as a black box. It just tells us whether it is a normal, immature, mature, and what is its confidence. So that is how we do it. Right. So for now, so we've understood we have to capture images and how the model works. Now let's get into the nitty-gritty of how it will be. So we capture a lot of images. Okay. Once image capture is done, we label those images. Once labeling is done, we have a lot of people who are going to check for this, if the quality is good, is everything all right, and then we split into partitions and train our model, right? I'll just show you one of the portals we use. For example, this is a portal we use for annotating of images. So we use a lot of open source tools. So this is something called as Label Studio, right? So this is where our basic process starts, where we upload a lot of eye images or oral images and all, and we want to create the reference. For us, a doctor is a reference, right? For us, let's say I'm going to teach you as to how to train a model. I have to give you a lot of examples, right? But I cannot have a doctor all the time. So I ask a doctor to take these images and tell me, is this normal, is this cataract, is this immature, is this mature? So Label Studio is a software which is used for annotating images. This is an open source software, so you can easily ask your students or you can yourself install it. Are you aware of how Docker containers and all work? Right, we'll get into that. So basically you can install it and run a server. So right now it's running on Logi backend. So that's the domain we use for our backend services. So this is it. So let's say I want to delete it. Let's say I want to consider, okay, this looks like a normal eye. So again, we just create these images. So let's say if you are doing a hands-on session with your students, you give them images, you ask them to do annotation. This becomes an interactive work for them. And then once the annotations are complete, you can go here and export the whole data in the format. For example, in this case, we want to use YOLO, right? So all the formats are visible, right? You can use whichever model you want. So again, this is Coco, Pascal, these are all formats. It's not something new, it's just way of representing the same annotations in different formats. Okay, I'll go back to the presentation. Right, so any questions here? So we capture the images, we put it into software like Label Studio, which is going to do the labeling for us. This is Label Studio, and then again, when we are training an AI model, we want to create a test for our AI, right? So let's say we have 100 images, we are going to teach the AI on, let's say, 75 images, and I want to test on 25. So training only happens on a small set. So I think that's a concept where you don't want the model to just memorize things. We want it to understand the logic behind it, so that's why we do it. So I hope you are aware of the train, validation and all these things. Yeah, okay. Right, so sometimes we have less data, so we augment it, we try to rotate the images, we try to flip the images so that we can create more data from existing data. Right, then we again do the whole training process, and so in the inference, when a new image comes, we first create proposals and detect the eye, where the eyes could be, and then we run a classifier, if this eye is immature, cataract or catcher, whichever, and then there is a threshold. Let's say we want the model to be 80% sure or 20% sure, that's where the gate comes, and then we have a verdict. Whether it's normal, immature, mature, if it's too low of confidence, we say it can't say. So it's a confusion matrix. So it's from our own paper in which we have 776 eyes, individualized, because we were looking at whether an eye has a cataract or not. So in this, let's say we had an agreement on 699 images, right? So again, this is the confusion matrix that says key true negative, false positive, false negative, true positives, right? From this we can create various metrics like sensitivity, specificity and all. Yeah, this one. Normal. So in this case we are saying cataract is positive. So this becomes true positive here. Okay, let's say what is positive. So in our model, let's say something has cataract is positive case. Not having is a negative case. The model is to detect cataract, so that's why it's flipped. So it's normal is a right negative. And cataract is a true positive. Mismatches. So some of these, right? So this is and it is very easy for you to write papers also because of such a structure, right? Today so much data is available online, and given there is a lot of push towards writing research papers and all, and with all these LLMs and all these tools that are available, it's very easy for you to publish papers. Right? We are able to publish papers very fast in that sense. Yeah, this has come after publishing a paper. And the same way, it's not that I did something very difficult, it's just that you need to know how to get the results, right? And all these things. So today we have data on, let's say, squint eyes, or you have data on simple things, right? You can build detectors around it, and that's a very good way a lot of folks are publishing papers. So again, it's a very open thing to do. Again, as you get into more of a specific problem, you'll add some nuances to your models. For this specific problem, I need to do this extra step, but still it becomes a novel thing to do, right? So on the oral front, we have a patent also. It's a process patent, right? How the process happens. Because I cannot patent convolutional neural nets, right? So again, patent is also like art. You have to know how to file a patent to get a patent, right? So we had a good process, how we followed, how we were rejecting images. Because these are user taken images in case of oral, right? You have to take, is this blurry? So sometimes people upload the picture of their dog, right? So all those things need to be handled. If you handle it in a novel way, you just write the process and that can then be patented. So this can heavily increase the IP output from you guys, right? In fact, each student can work on a separate use case if that is the kind of volume. Yeah, that's the kind of volume you can, because you just need one or two inventive steps, right? You need two important things. One is inventive step and another is utility for a patent to get granted, right? If you get that inventive step right, utility you can somehow justify, right? So yeah, so I can give you an example from this particular software. You can use any software you want. We've also built our own software in the past, right? So let's just say you want to use, you want to do annotations, right? So in this case, you have to, let's say, create a project, right? So again, in this we have to import data. Okay, there are many ways to import data. Let me see if I have something I can load. Add one image. In your case, you'll be adding 100 of images, right? And then you just save it, right? So now we have created a project. It's called new project. So it will show up in our projects here. Let's say this is the new project, right? Now we want to add annotations like labels, right? So let's say we uploaded a oral image in our case. So I'll just copy one from here. So this is the format in which we justify what we want to annotate. So if you see here, the labels are stains high, stains low. In your case, it could be, let's say if you're working on some other solution, let's say cataract, then it will be like MHO cataract, cataract normal. So this is like a XML format in which this understands what annotations to add. This is giving you an example of what it is. This is stains and low, stains high. So again, for our case, we'll just copy this there. Again, it's like this particular software requires you to do it this way. So yeah, I would say. If you want to do the annotations automatically, let's say you have an LLM, you can ask it to, but it's not good at drawing. So yeah, right now this process is manual for now. That what gives your research some value, right? That you have some data on which you are doing some work. Otherwise, you will be using one model to train another model, which might not give you like useful output, because that model already did the annotation, right? What's the use of your model then? Am I making sense? So that's the only step you have to do that's going to require some effort if you want something new. You have to do for many images for the AI to have. Image by images. In this case, when you are doing manually, it is image by image. That is for inference. Once your model is trained, you can run on thousands of images. But when you want to train something, for the first step, you need someone to give you reference. Ki this is right, this is wrong. If a computer can do it, well and good. But if not, you have to need a person. And for most of the healthcare use cases, you need a doctor or someone who do it. Or there are websites like Kaggle, RoboFlow, from which you can get a lot of data. Right? You can skip that step. You just give an attribution to this data I took from this website. And then you can build your models on top of it. Right? Now there are a lot of innovative things that people do. For example, do you know how they detect whether an image is AI generated or not? Huh? It's a good question, right? Like we have so much data today, whether it is AI generated or not. Let's say I have two images of a car. I have to identify which one is AI generated and which one is not. Okay, we do a lot of work for insurance, and this is now a new fraud that is coming up. I'll give you an example just so that you know. Right. So if you see this particular image, so there is some damage on this car, right? Right. So now what a lot of people do is when they are going for renewal of insurance, they want to hide this damage so that in the next insurance cycle, whatever happens to the car, they'll just claim this happened due to that accident and they want to get it repaired for free, right? So what they do is, they will upload an image like this. They've processed the image, right? They've removed all the damage here. Now they upload this image to the system. They'll remove all the possible traces. Let's say metadata has ChatGPT, file name has ChatGPT. They'll, let's say, remove it. Now the question is how to detect such things. Right? Because from till this point we knew that if a human can detect it, I can train an AI to detect it. That's where the interesting aspect comes in. We can. Can you like think of what could be a possible way? Yes, this neat picture. Yes, that's the interesting part. Huh? I'll tell you how it is done. So, the thing is, what we then try to understand is what an original image means. Right? When you take it from a camera, when you take it from your smartphone, when you send it over WhatsApp and still something remains. So, that's basically the noise. The natural noise pattern is different than the AI noise pattern, right? AI is trying to create an image in a certain way that does not match with the natural image. So we try to create, it's called as a spectral image, where we try to see what's the noise pattern here, what's the difference between the pixel bits, right? A natural image has a certain pattern. So what we train our AI to detect is a natural image noise pattern, right? So what we give is, we even don't need a artificial image at all to detect whether this is, basically our data set is only real images. We teach it, this is, so let's say, you know embeddings to some extent. We take some information and then we try to embed it in a big vector space. Let's say my name is Anand, right? And let's say, okay, let me give a good example. Okay, let's consider an apple. Okay, we want to put an apple in a vector space. We put, let's say I put it as point 0, 1, 0. Let's say it's a three-dimensional vector space. Apple is 0, 1, 0, right? Now I have poison, right? Now poison will have some like 50, 100 or something because these correlations are like almost nothing, right? So that way a vector space allows us to put objects in it. And the distance between those objects helps us understand the relation. Is it very much related or it is not related at all? Am I clear till that point of time? In a similar way, we try to create a noise pattern of this. We try to put in a vector space. And then we take an AI image. That noise pattern will be far from this. That's quite an analogy for you to understand. Am I getting? So basically, a normal image is an apple and AI image is a poison girl. So it will be a little far. So such kind of things are done. So that's the inventive step I'm talking about. When the people sat and thought about how to do it, they just have to think of one inventive step. Here it was to not look at the image but to look at the noise. Once you get that, then you use your normal AI to do things. But that one mental step is what makes the difference. You, like, maybe one more. You can do it. Once you know how, let's say, what is a skill? Let's say, a skill is when you have enough opportunity to test your skills, right? So an AI can learn a skill. So if I give you this model, this is how it is able to detect. Now you have enough opportunity to test it, to build your own model that can beat this, right? So yes, if I give you the model, you can iterate to do it. Yes, that is true. So this is how it is done right now. If it's a, it's hard. As the models are improving, it's becoming even harder, right? Yes. I generated it. So how the models are doing it, the one that I suggested is it's looking at pixel differences between like edges and pixels. So that noise that is being generated is different from that's what you are training. You are training your AI models on the noise rather than on the image. I think. Yes. I cannot do it. No. Again, each one is very specific. For example, Google adds signature to their images. So let's say you generate something from Gemini and then cut off the Gemini watermark that comes there. It still has some pixel patterns that Google uses as signature, right? But that's not the same signature ChatGPT might use. That's not the signature that Midjourney might use, right? So there are just so many providers and no one is using a standard protocol. That's where we need to create a system which is common among all and can detect. That's what Google thinks should happen, but that does not work, right? That's how Google thinks it should happen. That's for Google. I am not saying that's how everyone is doing it. Let's say ChatGPT. For example, let's say you upload an image to LinkedIn that is generated with ChatGPT. It will be able to identify that it's generated with ChatGPT because of that signature. In the same way, Instagram also has an auto tagging now, which tells this is an AI generated. Everybody is trying to build that AI detective tag, right? This is one way they do it. So yeah, it's a very fast moving field right now, where people are trying to detect AI. Ideally, they want users to put it, but people don't put it, so they are trying to build detectors for it. It's not mandatory, but they want so that people. They already do it for copyright music, they do it for copyright videos, now they are adding for AI. End of this session. Any questions for me? That will be a hands-on thing. It will be more. Not today. It takes a little longer, but I will tell you how to build an application that you will host. That it will be your application, it will be your use case. Just we will use LLM as the intelligent layer there, so that we can deploy it fast. Right? If we have enough time, I'll show you how we can deploy our own LLMs on systems. Right? But that needs GPU and also if we have time, I'll show you how our GPUs run those LLMs. But yeah.
Much, sir. We'll continue with the afternoon session.
So I think we had a very huge amount of interest towards patents. So for the first 5-10 minutes, we'll just go through what a process is like. I'll be talking about the patent we have for the oral product, right? So you get an idea of how to connect the dots, right? So what do you need for your patent for your patent? Do you think you need something to be built for a patent to be granted? Or it just needs to be an idea? Right? Yes, you just need to have a thought, just an idea to apply for a patent. It may not be useful, it may not be this, but an idea is basically what is a patent? It's a legal right that you are saying ki I'm going to make my invention public so that everybody can use it, and the government tells you, okay, you make it public, I am going to protect it. That's the basic contract that happens between you and the government when you make your patent public. And then you have the rights to use the patent, you have the rights to license the patent, right? Now, once you have an idea, we need to understand, has someone else done something like this or not? And that is where the first step of the patent comes. And that step is the patentability search. In the patentability search, what happens is, they are gonna first try to understand ki, okay, what are your key concepts, the keywords, right? So you have to identify ki, okay, this is my concept and these are all the keywords related to it. In my case, it was an oral screening platform, right? We are doing oral screening. So we were thought about, okay, what are all the possible keywords? So these are all the keywords that they came. Because a person like you and another person might not have used the same words, right? So we want to be a little thorough about it. So we try to find out every single keyword. So we go through all these things and then we try to figure out, okay, which papers or patents are there which already exist. So a patent officer wants to grant you patent. He really wants to. Just he has to follow the rules before he can grant it. If you can find a loophole for him, he'll be happy to grant you, right? Then we were able to find, let's say 5, okay, one more is there, I guess. So these are some US patents, these are some other research papers, any published information, anything, even if it's a research paper, if that information is in public domain, it is called as a prior art. A patent is an art. Anything prior to this is prior art, right? So before my idea, let's say I got this idea on 8th July, anything before today, I'm going to search if it exists in any of the published, it could be a blog, it could be a paper, it could be a patent. Anything published for public consumption makes it a published entity that will be used to scrutinize your idea, right? So that is how it is. And then what we do is, against each, we try to figure out, okay, what is it? Like, how is it similar to my patent? Again, this is like a big graph, but we try to figure out, okay, where are the similarity, where are the dissimilarity? We have to make it a very structured process. So that when we say, okay, this is the patent I am comparing it to, what is that exact difference? And then what we do, based on all this search, I am supposed to fill out, okay, what is the small difference, small difference, small difference. All those differences are basically giving me a direction. Okay, I'll write it this way. That's how I will protect myself from this prior art. I am doing all the process that the patent officer is going to do. Right? He is going to do the patent prior art search. He is going to figure out, okay, this patent is similar to this. But because I already did it, I will be able to tell him that this particular point is where it is different and why it is such an important point. This helps you pre-prepare for that to happen. So in a patent, when you file for a patent, the first thing is application. Second thing is a person is going to go through it. That is the patent officer. And then if he feels something doesn't feel right, then he is going to ask you for a hearing, where he is going to put up his points. Again, it's a very formal process. He'll tell you the points. You will have some time to answer it. Then there will be a video call in which you have to explain him why this is important, right? But the process that he is going to follow is not a black box. He is going to do for a prior art search. He is going to figure out the similarities, and he is going to see if there is an interventive step when compared to this particular paper or not, right? So this is how you do the prior art search, right? All this thing is there again, all the comparisons and all. So this is there. After this, Now, this is the last pages of the paper, and this is the most important part of a patent. What are you claiming to be a unique aspect, right? So here in this particular document, there are I think 10 or 11 claims, right? The first says it's very generic. You want to keep your patent as broad as possible. Like my broadest patent could have been I am building an image analyzer, right? That's the broadest I can go. I'm building an image analyzer. But then you see there are so many patents around it. So you narrow it down a little so that gives you a advantage. I'm saying I am oral expert, now I am building an oral image analyzer. So that's why we wrote a system. We call it as 100 and all these things just for referencing purpose. Is generating an artificial intelligence based periodontal status report. Right? I could have written only the 3 use cases I was working on, stain, calculus and caries, but I want it to be broad. So I call it periodontal, all these things. You want to go from broader to specific, right? To focus on your niche, only to the extent where you can protect your patent, not more than that. Otherwise your patent will become too specific. And tomorrow, when someone else is filing a patent, they'll say, okay, this person only wrote stain, calculus and caries, but today I am doing gingivitis. So that is the inventive step. We don't want them to get that, right? We want to create a strong patent that tomorrow that person has to come to license your patent. That's your objective. To keep it only narrow as possible, to pass through the patent officer, but not too narrow so that anybody can write a patent around it. So that's where the art aspect comes in. So again, this is like the main claim, and then there are derived claims, right? Again, in patent law, overlaps in patents are also allowed to some extent, but most of when someone goes to the patent office to file all these things, it has to be broad enough to cover everything so that nobody can go around it, because even a small overlap in a single claim is considered an infringement and you will get a benefit of it. So this patent has some 10 claims. So this is there. Again, this is the claim part. So I think 10 claims are there. So again, there are 2 numberings. So this is just point numbering. This is the claim number. Okay. And then there is this whole document about the specification. Now, when you have an idea, writing this big of a document is not possible in one go. It's going to take some time, but you want to protect your patent when you got the idea, and that is the time you file a preliminary patent application. You just have to give one short idea, this is what I am going to protect, and you file it. So we filed it in December 2020, the preliminary application, right? And then this whole document was filed in November of 2021. But when it got granted, I got a protection from December 2020, right? So if you are feeling very strongly about an idea, you can file that preliminary application that gives you retrospective protection. Okay, so that's how you go along a patent process. Any questions about it? Right. And just to add 2 more points, one is prior art, second is they look for an inventive step that separates it from every other prior art, and third is what they look for is utility. Right? If you are not able to show a utility, let's say you are saying that this way of folding a paper is very unique, but if it has no utility, they will not grant it. Right? When I said an idea is enough, this is one restriction to it. It has to have some utility. If there is no utility to it, the patent officer is, why should I grant you for fun? Right? So that we don't want to just inflate the number of useless patents in the country, right? It just has a inventive step but no utility. So yep, that last step is utility, where you try to show. In our paper we showed that these many people in India face this many issues, right? Not everybody can go to a doctor, so we are bringing the first level of screening to the user at their phone. So that is how we were able to show them utility. If you have already research papers around what you are doing, that also gives a strong stand to your patent. So, yep, that's pretty much what a patent is. Any questions? Right. So, ठीक है, then we will now move to the hands-on session we have today. So again, the idea was to look at generative AI and all, right? So what we will do is, in most of the scenarios, we don't have all the GPU capabilities in the world to run our own model. Let's say these computers may not have the GPU strong enough to run that model. So what we'll do is, as a hands-on session, first we'll show how to put your idea through while using external APIs. And then we will also, if time permits, I'll show you how to host your own LLMs, right? Maybe I'll just spin up one of my company's GPUs and maybe I'll show you. It's not that big of a process, it's just a command. Okay. So for the hands-on session, so how many of you have a GitHub account or you know about GitHub? Right. So basically Git is something that Linus Torvalds, so you know about Linux kernel. So that man got fed up of managing too many folders. He was like V1, V1.2, V1.3. So he got fed up of it. That's when he created Git, so that he could just keep that project properly, and then he open sourced it and it just boomed, right? And from there, the Git protocol came into existence. And then GitHub is just one of the repositories. We have GitLab and we have private repositories and all these things. So that's where we maintain code. For today, we are going to use code spaces. It's a feature of GitHub that allows us to code without having any internet and without having dependency installed on your system. So you have Chrome or Firefox in your systems. Can you log into GitHub or create the account? Yeah, it's a hands-on session, right? So now, once you're logged in, please search for code spaces on Google. It will show you a page like this. So the reason we are doing this is because, see, all these systems are so many systems, it will take a lot of time to do the setup and all. So this kind of gives us a quick access to all the prerequisites, so we can start coding directly or doing things. So this is GitHub code spaces. It gives you a very small instance in the background. It's a Linux system. In code spaces. New tab, search for code spaces. You will get started for free. Yeah, get started for free. Are you on this screen? Just go to see all. We want to build our project using Next.js, this one. So Next.js is a node-based library. It's a very lightweight library, and it has a lot of interesting ways we can deploy it. That's why we are using it. It's better than Python in terms of speed. Python is better in terms of processing and libraries for ML. So this one, use this template. As soon as you click it, it is going to start that instance for you. Yeah, so now it's going to open Visual Studio for you. So you are basically being given a small instance at a distant server. It's being connected to Visual Studio where you can code, right? Here, eventually, on the right hand side. Of Next.js is, so there are many ways in which you can develop a website. You can have one server just hosting the UI and there is a backend, right? So there are multiple ways this can be done. In Next.js, you write one code, it acts as the backend as well as the front end. So one server. It has a lot of capabilities. It's very powerful in that sense. It's lightweight. And in fact, if you build an application, you can host it for free. If you have an AWS account, you just go to Amplify. There you just import the repository and it will host it. So a lot of our simple projects are hosted on Amplify. Yes. So this is some very what we do stuff. Has it loaded for you guys? For me, it's taking a little longer. Yeah, it'll run for some time. Yes, it has both front end and back end. Ah, okay, this has come. Just give me a second, it's loading up. Yes. Acha. Go to here, search for code spaces. Just remove the whole GitHub thing. Yes. Yep. The first one. Now the idea is that we will create a simple application which is a healthcare application. So just choose an application you want to build. It could be like in my case I had built a squint eye detector. You know squint eyes? Basically eyes are either inward, so they are not like in sync in this way. They are a little off. I'm not sure about the Hindi term, but yes, squint eyes. I'll show you an example what a squint eye looks like. I think my internet is slow. So this is what a squint eyes looks like. Right? So in my case I'm building this. So you can build anything you want. We are going to use simple. We are not going to train a model here. I'm just teaching you how to build an application so that you can show these kind of applications in a nice way. Right? We are going to use the intelligence of an LLM right now. And then if time permits, I will host my own LLM so that you guys can use it. Okay, that's the idea of it. So with that, let's say, in this case we'll use a little bit of LLM to build this thing because we don't want to sit and code here given the restriction of time. So if you see on the left side panel, there is a chat window. Is it there in your case? In the main application, here there is a chat window on the left hand side. So have you used GitHub Pilot before? Copilot? No. Have you used? Okay. So you can just have a quick conversation with him, ask him what is this project about. Right? Just so that you get initiated. Yeah, here in this chat window, you can just ask it. You can write it here. There. Start writing. So you can just ask it, what is this project about? Yeah, it's going to think. Again, it's on auto mode. It's going to use whichever LLM is available to it. On the bottom, it will have a chat option. Is it there? That one. The Copilot. Start. Yes. Use AI features. Yes, there. So what we do in our work is we do a lot of experimentations. So our time mostly goes into planning what needs to be done, and a lot of LLM is used to execute it, right? So given you are also in that position where you have to tell people what to do, I think you will be in a good way to instruct these sort of systems, right? So did it answer you what is this project about? It's reading. So it's saying, so again it tells you whatever steps it has. So do you know how an LLM works eventually? Yes, so before we proceed with finally using it, I'll just give you a quick preview of how an LLM thinks and works. Right? What was the inventive step there where we made a lot of difference? So basically an LLM is like encoder decoder. For example, I am talking to you in English, right? But how your brain is keeping it stored in its head is not known to you or me, right? That is the same way in which an encoder decoder works. So after they say, let's say I say hi to you, you are going to say hi back to me. But what your brain understood, how it stored that hi, is not known to you, not known to me. I don't know how many neurons got activated. It's a black box for us. In a similar way, when you give a prompt, what is this project about? It goes to the LLM. Now its objective is to create the next set of words, right? So there is a huge embedding space in between which acts like our brain, right? So how an LLM is trained? It's basically trained, let's say, they say they are using my data to train the LLM. That's the usual statement they use, right? So what is being done is, they take a lot of data from the internet. They give key once upon a time is the starting statement, and then the model is supposed to say in Mumbai, right? So they keep asking it to predict the next word, the next token, right? And that is how they try to build that black box. Am I making sense, or it's still not clear? Yes. If I could draw, it would have been easy. This is a simple example. Here is where you give the input, right? There is an encoder that is going to convert that information into a big vector, n-dimensional vector, right? It's a matrix. It's going, let's say you say ki, hello, how are you? Then it is going to convert this all information into a huge number, list of numbers, right? It's a vector space. Are we clear till that point? Then we assume that here there is a black box in which the parameters need to be trained, and it is going to detect the next word. Let's say I say once upon a time. I enter this. It goes through my big neural network, and then the decoder gives me an input in Mumbai, right? So if it is not in Mumbai, again that process comes where we calculate the error, we try to change the model parameters, and then the whole training process happens. So when they say ki I'm going to use a lot of data and a lot of computation to do this is what we do. We give it a lot of input examples, and we give it a lot of compute power, and we assume that this black box is going to learn something, right? Now when you said what is this project doing, it sent what is this project doing, then you must have read it did a lot of instructions. I'm reading this file, I'm reading that file, I'm listing this, right? That's what it has been taught. Ki when someone asks what is going on, the first thing is say I need to read this list. When it sees ki it needs to read this list, it's going to call a function that's going to do the ls of the directory. Then it's going to send back that information. Then that loop continues till it decides to stop. Once it has read everything, once everything is in its memory or prompt. So in this case, the LLMs that we use are stateless. Everything has to be supplied from here, right? It does not remember anything you say. Your ChatGPT chat remembers because apart from your recent chat, it sends the history. Okay. So are we clear how this LLM is working right now? So in your case, when you said, what is this project doing? It sent it to the LLM. LLM said, okay, my first thing to do is, I've been trained that I need to list whatever is there. Then it listed it. Then it said, okay, these files seems important. I need to read this. Then it's going to recursively read those things and feed it back to itself. And that is how it came to the conclusion that this is a demo application and whatever it wrote. Are we clear till this point? Right? So the reason I'm telling you this is so that when you teach someone, you have an idea of asking these simple questions and what to answer and all, right? So this is there. Now, why don't you guys decide what you want to build? In this case, let's say you want, what do you want to build? Or do you want me to tell what to build? We'll build a squint eye detector. Whoever wants to build something else can build it. That would be clean. So let's build a squint eye detector. I already did it this morning. It's a very simple thing to build. It's apparent to us, right? So let's say we'll ask it to build that for us. Let me see if my system started running or not. It's mine also started working. Okay. Yes, so in that case, now let's write a prompt ki I want to build a squint eye detector. Okay. In the chat, we are not going to code at all. We are going to ask it to code for us. A squint eye detector. That's fine, okay. It's doing npm run dev, fine. Here we'll do it, right? Yes. So in this case, we will say ki we'll be using an LLM to build it. So we are going to use open router. I'll tell you what we are going to use to build this detector. Okay. So there is something called as an open router. Basically, this is a market of all LLMs. Okay, this is one such place. Let's say today Google has an LLM, OpenAI has an LLM, Anthropic has an LLM. I cannot sit and manage all those keys at the same time. As a developer or as a person who is doing research, I want to be easily able to switch between models. Some models might have some advantage, some others might have some advantages, right? So, for example, today it has a good ranking system which kind of tells you which model is performing well on which task. You can find a lot of models, right? So here we have DeepSeek. You must have learned the Chinese model that is really performing well. Some Mimo, GLM, and Claude is there if you know about Anthropic. So what we use it for is open router. It's basically to route your prompts to any of the models that are present out there. You use a single code base, you just change a variable to change the model you are asking for, right? Media pipe and all. So I'll give you the exact instructions. If you can write it, that will make my life easy. Okay, so what we'll do is, let's just think about what the structure has to be. So we have a UI page on which we are going to supply a URL. Let's not be worried about where we'll upload and all. We'll supply a URL we copied from the web. Okay. So we are discussing the architecture. This is the most important part of working with an LLM. That is what instructions to give it. Right? When you wrote, I want to build a media pipe, for some it gave a squint eye detector. For one it will give a media pipe instruction that I am going to figure out where the eye is, I am going to calculate the distance, all these things, right? So that's what happens. When you give a simple instruction without specifying what you want to do, it's going to do whatever it wants to do, right? But we have some structure in mind, and that is where your expertise come in, where you have to plan. You have to talk to it, you have to plan before asking it to execute, right? What we want to do, we want a page. In that page, we will basically have an input area where we'll put the URL. We want a preview to also show up so that it looks nice, and then we need an analyze button, right? That's what we want today. Once the analyze is clicked, we want it to call an API that is going to call an LLM to fetch the response and show here. This is my planning today, right? If I don't give it the plan in this way, it's going to create anything it wants. Each of your implementation will be different. For some it will go pure computer science, where it will try to analyze pixels, right? So that's where one extra step is going to make a whole lot of difference. That 1 minute you sit and think what to tell is going to differentiate the outcome that's going to come out. So did you understand the architecture we are looking at? Just mention that we'll be using open router for the API, it will understand. So did you understand? Can you write it in your own words in that chat? This is what I wanted to do. Do you want me to repeat it so that we do it again? Okay, I'll just repeat it. So I want to tell him, I want a page on which I will give the URL of the image, right? Show me a preview of it, and there is an analyze button. Once I click the analyze button, it has to call an API to which will eventually call open router to fetch the results of whether this is a squint eye or not. So yeah, so you have to type in your own words what you understood in the chat. What? I'm not getting what is. Yes. Prompt it. I will tell you what to prompt. Text takes the URL. Of an URL of an image, and a button which will analyze button which will call one API Yes, we should call an API. So what we are learning right now is, one, we learned how to structure our problem here, right? And then how to feed it to LLMs. API, which will eventually call open router to fetch the details. Open router. You'll understand. Open router is a well-known term. It's a well-known term. You'll understand ki whether again whether it's a squint eye or not. So with the image, that whether it's a squint eye or not. That's what we are building here. A simple generative AI application, and then we'll make the LLM our own too. Yes, as simple as that. That's yes. While you know a lot of basics of computer science, if you want to understand what's happening in the world right now, this is what happens a lot. And apart from this, they expect you to know what the basic computer science is. Yes, it is. But in this, it has to be. What I am trying to tell you is how it is done today, so that there is not a disconnect between what you are thinking is someone is sitting and writing if-else statements. That's not happening anymore, right? But what that statement has to be is what you architecture. So that difference has come. I'm just giving you an idea of what it works like. Huh? Yes. Okay. That's fine. Let it complete. Has it? Okay. Yes. So we'll create the .env file now. Right? See, if you no, that you have to do. The env files are environment variables. These are secret things. We don't want to give it to the LLM directly. Yes. See, while you may say that this is a simple thing, I just told him what to do. But if you don't understand what is it answering you, you will not know कि आपको करने का क्या है. So even if let's say you don't know anything about computer science and try to build an app, it might not work that way. It will be at the mercy of that LLM. Coding is still alive. It's just that you have a better tool to execute it. But if you don't know the basics, it is going to use some unoptimized part to build it. Here itself, you just ask it. You define the page you want and the API you want. You know what an API is? No, let's just go to that page, that chat once. The code space chat, here. This one I think. Here, there. Did you write that statement I asked you? Okay, you have not written. So let's just start there. You ask it to create a page. Did all that. Or I'll write it here so that. Are we getting? So where are you right now in the journey? Is it asked? So we need to create a .env file now. Now this part you have to do manually. I'll give you the. So is there a way for me to give you the API keys? Like I'll send it to someone. The router API key. See. Yes, I will just paste that key in that group. Hello. Yeah, it just was added now. Right, so in this specific key, you just go on the left side on VS Code, and there's a button, right? You just need to create a new file. It's called .env. it's a .env file. You just store that text I've given to you in that file. So just click on this plus button and then it will create, name it as .env. The .env is the usual syntax we use when we are trying to declare a secret. Yes. You just paste that key there. Yeah, is your app built? Yeah, looks good. So let's just open it on a new page. That one. Okay. Yeah, now let's just go back there and we just search for, yeah, copy, like, is it a right click on it, copy its URL. You can search for another image. Or maybe you'll get a simple image. Open this image. I think this has a simple. Click it. Yep. Yes, so I think everyone's API part and UI part is working, right? From an analyze, you are able to paste the image, see the preview, click the button. Is anyone not there yet? It's working for you. The image results are not coming. The API is not working, right? Only that final part where you click the button and the results are not showing up. Have you reached till that point for everyone where you give the URL, the image shows, but the analyze button is not working? Is it the case for everyone? Anyone who is not there yet? Do speak out. Till this point, yes. Now what is happening is we need to give it an example of how to make that curl request. Right? You know how the REST APIs work? RESTful frameworks, there is a post, get, put, delete, update. Yes. So what we are trying to do right now is we are going to make a post request. Right? There is a certain format that needs to be followed. In most cases you see the LLM is not able to get the correct format. In her case it was saying image text. In some case it is saying image URL. So these are again another limitations where you have to give it a sample so that you can proceed further. Otherwise you will be stuck if you are completely dependent on what it does. Right? So I am going to paste this URL, curl code. You just paste it in the chat and ask the chat to follow to make the API following this curl structure. This should fix that final step problem. In the WhatsApp group, it's a big curl statement which will give you the result. You'll have to somehow copy it to this system. Yeah, everything. It has the key also. I have created a sample key which can be used. It's the same thing. The concept is the same. It's just that, let's say in your case, it says input image, all those things. So it's not able to understand the correct structure. Yes, in the chat. Yes, so, done, right? For you guys, yes. Were you able to do? No, yes. No. Okay, I think we are towards the end of this discussion. We'll keep that hosting your own LLM to the next one if ever that happens. So, too many things I have told you guys. In any case, you have any questions? Any other questions? Any questions that are unrelated to this that you would want to know? I'll just give you a brief of what I have done so far so that you get an idea so you can ask questions. Founder of this, my company for the last 8 years, 4 months. I started it in college. I worked in DBpedia, it's into knowledge graphs. Basically, let's say Barack Obama and Michelle Obama has a relationship of husband-wife, right? That is how Google stores data, right? When you ask for who is the wife of Barack Obama, it has a lot of knowledge graph inside it, right? So that it knows that Barack Obama and Michelle are connected as husband and wife. That's why you get split second answers, right? Doing it with LLM is just not that effective. It's just too expensive to do, right? I was working with Google Summer of Code with this organization. Are you aware of Google Summer of Code? So basically it's a program by Google in which they want to promote open source, right? So I worked for DVPD and Google paid me, and they pay a lot, right? So for example, they pay close to $6,000. It's like 6 lakh rupees, 7 lakh rupees for a summer. In India, I think it has been decreased to $3,000 now. Still, it's 3 lakhs a summer. That's good enough money, right? So again, in that case, I worked with DBpedia on one of their projects, and I was paid by Google. So that's Google Summer of Code. That's very relevant for you guys, right? Then I was software engineer and all. We'll go to this part. Publications, again, a lot of publications around AI models. That one is cataract. We worked in micronuclei in DNA damage analysis. Same image analysis process I told you about cataract was used in that. I've worked a little on large language models. Again, one of my first papers was this long short-term memory cells. It was basically video analysis. So when you use YouTube, right, when your network is bad, the quality goes down. When network gets better, the quality goes up, right? Predicting what has to be done is the interesting part. Before anything happens, it is analyzing your network, your bitrate, to tell what next happens. So that this project was all about it. I was continuously checking what's the quality and then telling, from this to this, send me at this quality. From this to this, send me at that quality. So that's where the AI was used. Again, this is again knowledge graph based thing. And apart from this, I think as a professors, you look for a lot of research grants, right? Research grant form a big part when you start doing project, because that gives you a lot of budget, right? It gives you budget to get more students and all. So I've got research grants. So this is the Biorecognition grant. It's one of the topmost grants for ideas. If you have a good biomedical idea, those guys are willing to give you 50 lakh or more to nurture that idea. So again, that is one of the grants we had got. And then rest are competitions, in the sense startup competitions and all. Again, hackathons, startup competitions, some DRDO related competitions. So that's the kind of background I have. So if you have any questions in these backgrounds, you can ask. Even grant writing is also a very interesting work to do. I did my bachelor's in computer science from IIT Bhilai. It's one of the new IITs. It came into existence in 2016, and I was the batch of 2016. Yes, there were like 100 folks. Yeah, so yeah, that's the things. So do you guys apply for grants and all here? So that's why if you have any questions about grant writing, do ask. Huh? Sure. Yeah, sure. So yeah, that's what we do. I think it was a little bit of a hectic session, I believe, in terms of the hands-on. I do understand, but that's how the world is now. If you face so much friction, that's the friction your students will also face, right? So that's where we are today. Yes, a lot of things at the same time. Okay. Yes. I think we'll close the session now. Anything else? Thank you so much. Most of it in sales now. Yeah. 3 or 4 folks are in tech and the rest are doctors and sales. See, the thing is, freshers are something that are facing the biggest heat right now, right? People who are already in the industry are not that in a difficult position. So Yeah, somehow they are managing, but still a very grim situation in that terms also. But at the end of the day, it's not going to eat up all the jobs. So smart people are going to remain smart. So if they are able to apply, the way we sat, we tried to apply some things. See, nobody wants, the way I was teaching you everything, right? कि अच्छा ये यहाँ है, ये यहाँ है. In job, they don't want to do that, right? The guy has to understand how things are. They have to see, knowing computer science, knowing data structures and algorithm is the basic. They expect you to know that, right? But at the same time, they want you to be smart, know about technology, know about different things going out there. Yes, something like that. Yes. So at the same time, they expect you to know the basics. At the same time, they expect you to be like know all the fundamentals. Huh. See, you need not know about the tool. See, you knew what coding is. I just gave you another way to do that coding, right? It was just, now you know. Let's say tomorrow you do a session and you want everybody to have the same environment. You'll ask them, open up code space, I'll give you a problem to solve, right? It's just a tool. So if you have your fundamentals right, then getting introduced to a tool is like getting introduction to a new language. The if else statements are going to be there. It's just how you write them, right? So fundamentals still matter. So a lot of people don't know what HTTPS is today. What is the difference is there? Such questions are asked. Uh-huh. Oh, yeah. Most of our works is I'm not sure, sir. Working is the one that. Yes. To really know the basics. After that, these things accelerate stuff, right? And if a person knows the basics, catching up to this is not difficult. So if I am going to test someone, it's still going to be on the basics, not how well he is able to prompt. That he can learn in a day or two, but basics he cannot learn. So, yeah, still the same TSA algorithms and stuff. But yeah, that is the base. Sure, sure, sir. Sure. Thank you so much, sir.